Okay, during Mechanics 1 we're going to look at various different forces, and I'm going to introduce some of them forces to you now. Now, Newton's second law of motion states that the force needed to accelerate a particle is equal to the product of the mass of the particle and its acceleration produced. So, what this means is the unit of force is newtons, and it is defined by the force which causes a 1 kilogram mass to accelerate at a rate of 1 metre per second to the minus 2. Now, it's really important in Mechanics 1 that you differentiate between mass and weight. Mass and weight, well, weight is the force of mass under gravity. Okay, so you've just got to make sure you get the two right, and we'll look at that again in a minute further down this video. Now, the formula which we're going to use a lot of in Mechanics 1 is force is equal to mass times acceleration, which you probably know already, but that's going to be used a lot of during our Mechanics 1 course. So, this equation of motion gives a relationship between the resultant force, F newtons, acting on a particle of mass m kilograms, producing an acceleration of a metre per second to the minus 2. Now, this video is mainly to do with introducing different types of forces we're going to look at during Mechanics 1. Now, the first we're going to look at is the normal reaction. And the normal reaction is the force that acts perpendicular to a surface when an object is in contact with the surface. In the example on the previous page, the normal reaction is equal to its magnitude. Now, we haven't got that picture, so I'm just going to show you that quickly. So we've got a table, and we've got a book sat on the table, and because the book's sat on the table, perpendicular to that is going to be the resultant up here. Okay, you need to make sure you mark that on a lot of diagrams during Mechanics 1. The friction is the force which opposes the motion between two rough surfaces. So if you get your hand now while you're watching this video and put it on a table and force your hand away, the friction is going to be moving towards you in the opposite direction. Okay, so push your hand away, friction's towards you. And it's the same in everything. When you're driving a car, if you're moving forwards, the friction's in the opposite direction. If an object is pulled along by a piece of string, this force is called a tension. So if you've got a little toy and you've got some string attached to it, as you pull the string, the car moves along, and the force in the string is the tension. And finally, if you are pushing an object across with your finger, that's the thrust or compression. Okay, so if you've got a calculator like I have here, and I'm applying 10 newtons, say, I'm pushing it away from me. An object moving through air or fluid will experience resistance due to friction between the object and the air or fluid. This force opposes the motion of the object. So, friction in air can kind of be considered as resistance. Next one, gravity. This is a really important one again, and I said this before. It's really important to differentiate between weight and mass, and this little comment here will just remind us of that. So, gravity is the force between an object and the earth, discovered by Isaac Newton when an apple fell on his head. Ow. The force due to gravity acting on an object is called the weight of the object, and it acts vertically downwards. Remember, gravity always acts downwards. You know, I've done it, everybody will do it. Just be very careful to make sure that gravity is always acting downwards. A body falling freely experiences an acceleration of g equals 9.8 metres per second to the minus 2. Now, anybody who does physics, please be very careful here, because the difference between Mechanics 1 and physics is that we use acceleration due to gravity as 9.8 metres per second to the minus 2. Using the relationship F equals ma, we can write a formula for the weight of a body of mass m. So weight is equal to mg. It's very clear, similar to force equals ma. Right. When there is more than one force acting on an object, you can resolve the forces in certain directions to find the resultant force in that direction. You usually resolve in the direction of acceleration and perpendicular to the direction of acceleration. So you've got to do it in two directions at right angles to each other. In your answers, you should use the letter R together with an arrow to indicate which way you're resolving the forces. This is to help, because when we're looking at acceleration, it's important whether it's a negative, so it's going against the acceleration, or it's going with the acceleration. So it's really important that you indicate to yourself and the examiner that you know what you're doing by indicating which direction you're taking as positive and which one as negative. Right, let's look at two really simple examples. So, find the weight in newtons of a particle of mass 12 kilograms. So, weight is equal to mg, and we know that g is 9.8. So, the weight is equal to 12 times 9.8. Now, it is acceptable in some questions to help make it look neat by leaving answer in terms of g. But let's just get the answer here. So 12 times 9.8 is 117.6 newtons. Okay, question number 2. The acceleration when a particle of mass 1.5 kilograms is acted on by a resultant force of 6 newtons. So this time we're going to look at finding the acceleration. So we're actually using F equals ma this time. So the force is 6, the mass is 1.5, and the acceleration is a. So we've got to do 6 divided by 1.5 to get our answer. So 6 divided by 1.5 is 4 meters per second to the minus 2.